So we've got this infinite series here, x to the n over n, and we're looking for the center, radius, and interval of convergence. So we're going to start with the ratio test, which by definition is the limit as n approaches infinity of the absolute value of x to the n plus 1 over n plus 1 all over x to the n over n. And when this is less than 1, then we converge. And so I'm going to copy dot flop here. So x to the n plus 1 over n plus 1 times n over x plus 1. X to the n, we're looking for this to be less than 1. So this is really x to the n times x over n plus 1 times n over x to the n. X to the n over x to the n is 1, and the limit as n approaches infinity sends this to 1 as well, so the only thing we have is x. So we're really saying when the absolute value of x is less than 1, then our series will converge. And so that means that x is less than 1 and greater than negative 1. And so this right here, if we were to look at this on a number line, we converge at 0, and at 1 and negative 1, we don't converge. And so our center is equal to 0, and our radius is equal to 1. Because this are the values of x, where we can use this series to approximate the actual function that it represents. However, an interesting thing, whenever we use the ratio test, we actually have to test our endpoints, because we could converge at those endpoints. And so what that means is when x is 1, I'm really looking at the series 1 to the n over n, because this used to be x to the n, and for that x we plugged in a 1, because we're only looking at that endpoint of 1. Well, 1 to the n is just 1, and 1 over n diverges. This is a harmonic series with p series, p equal to 1. So that means when x equals 1, we are divergent, and so I need to put an open circle there. Or you can think of it as 1 with a parentheses. But I also then need to check x equals negative 1, the other endpoint. So when I do that, for x, I put a negative 1 to the n. Well, now, this is an alternating series that would be negative 1, and then it would be 1/2, and then negative 1/3, and then positive 1/4. Well, this is going to converge because it's an alternating series, and so that means that x equals negative 1, I have a closed circle or a bracket, and my interval of convergence is from negative 1 to 1, or x is greater than or equal to negative 1, less than 1. The radius of convergence was 1, but when I look at my intervals, I had a closed bracket at negative 1 and an open bracket at 1.